In this video, I will provide you visual examples of common igneous rocks. I'll describe the rocks by their composition and their texture, but it is your responsibility to refer to your notes to infer the rate of cooling and the crystallization and the location of cooling and crystallization of the rocks. Additionally, keep in consideration if the rocks have more silica content or more iron magnesium content. As I progress through, I will annotate or hover over the rock I am describing with a pen or a red laser on the slides where there are more than one example present. So let's begin. So for igneous rocks, I'm going to cover granite and rhyolite first. There are on this slide two examples of granite, a pink granite and a gray granite, as well as an example of a pink rhyolite. Though not shown here, there are gray rhyolites as well. Granites and rhyolites are both felsic igneous rocks. They are abundant in orthoclase feldspar, which gives both granite and rhyolites a pink color. Granites and rhyolites may also be gray in color because of lower percentages of orthoclase feldspar. Compositionally, granites and rhyolites are the same. However, texturally, granite is coarse-grained and rhyolite is fine-grained. Granite is a predominant rock that composes the continental crust. The grand views of Yosemite National Park are composed of granites. Next, we have diorite and andesite. Diorite and andesite are both intermediate in composition. Diorite is coarse-grained. Andesite is fine-grained. Observe in the diorite the visible interlocking crystals. This example of andesite is actually a porphyritic andesite. Pure fine-grained andesite is incredibly rare, so almost all andesite is porphyritic. These black, tabular, slightly irregularly shaped minerals are likely the mineral hornblende. Next, we have gabbro basalt, vesicular basalt, and scoria. Gabbro and basalt are both mafic in composition, which includes vesicular basalt and scoria. Gabbro is coarse-grained, and basalts are fine-grained. However, both vesicular basalts and scoria have considerable holes or vesicles. And when assessing vesicular basalt and scoria, where most of the rock is covered in vesicles, we call it a scoria as opposed to a vesicular basalt. So train your eye to observe the interlocking crystals visible in the gabbro, whereas all of these basalt examples are fine-grained and no minerals can be observed. Importantly, basalt is the predominant rock that comprises the oceanic crust. And an example are the Hawaiian Islands that are composed of basalts. Next, we have peridotite. Peridotite is coarse-grained, and it has a more pronounced green color from the ultramafic composition. The green color is largely related to the high composition of the mineral olivine. Geologists refer to peridotite as mantle rock. Obsidian is a glassy igneous rock. And while it may come as a surprise, the black color of obsidian comes from tiny specks of iron in silica glass. So while it is dark in color, obsidian is technically felsic to intermediate in composition, even though, as we recall, there are no minerals present because the rock was quenched so quickly and ordered repeating crystalline structure was never developed. Thus, it is amorphous. Our last example is pumice. Pumice is glassy and vesicular in texture and compositionally either felsic or intermediate. However, unlike obsidian, pumice has a frothy glass texture, similar to sponge sugar, I know it as cotton candy, or the froth of bubbles at the top of a soda that you maybe pour into a glass. Be sure to take some time to familiarize yourself with these samples. And for those samples that are coarse-grained or phaneritic in texture, see if you can point out individual minerals even in the photo. That's all.